I doing okay so far, you guys? Now I use my various different double angle identities.
Why didn't you just subtract and factor? I mean, you still did.
Because I need a 0 over here. So I'll bring everything to one side.
How do you choose to use a sine versus the cosine or the
Sir, I have no clue.
cosine squared?
I don't remember what I did when I wrote the solutions for the quiz. I'm just off the top of my head just grabbing one. And if I'm wrong, if I didn't choose a convenient one, I'll just take maybe sine squared and replace it with 1 minus cosine squared. I'm being honest. I really don't know what's best. Is that a plus 2 sine x cosine squared x? Minus 1 plus 2 sine squared x? I don't know, you guys, I'm being honest. Any like terms that can be combined?
Sine? Pull sine out.
You're saying I can pull something out. I'll buy that. Is there anything I can combine in terms of like terms?
How do you pull the sine out?
Factor out the sine.
Factor out a sine of x from what?
You can do the cosine squared, use another identity.
Which one?
1 minus sine squared.
See me right here.
Yes.
And if I dive in and make a substitution, I get this. You know, the upside to this is at least now I got an equation solely in terms of sines. As a matter of fact, taking a peek at this term right here, which is negative 2 sine cubed, I'll combine it with this one. Let me try to grab out my sine squared terms. You know what? I only see one of them right here. Now I'll grab all my sine to the first power terms. There's a couple of them. I got 2 right here, 1 more there makes 3 of them. I guess the only thing missing is any constant terms I might have. Do I have any? I got a minus 1. Well, at this stage of the game, I've got a polynomial expression of degree 3, for which is a polynomial in terms of sine of x. Do you guys mind? I personally don't like negative leading coefficients. You don't have to do this. Can I just quickly multiply both sides by negative 1, just to force it to be positive? Not that you have to. You'll get the same solutions I do. It just makes my life a little more convenient. But now using the principle of zero products, let's take those coefficients. I said principle of zero products. I'm sorry. I meant let's take the rational root there and plug in our P over Q's. Let's try one. Let's try it. Oh, look at that. Isn't that nice? That necessarily means this third degree polynomial can be factored into the product of sine of x minus that number up there times 4 times the sine squared of x plus 2 times the sine of x minus 1. But that necessarily means that the sine of x is equal to 1, or, let's use a quadratic formula, the sine of x is equal to negative b plus or minus the square root of b squared minus 4ac, all over 2a. Or shall I say, the sine of x is equal to negative 1/4 plus or minus, I don't know, is that a root 5 or 4? And now I got to determine what values of the output I'm going to actually choose. I can't. You guys, I'm serious. I remember the quiz question. Weren't we simply looking at this picture from 0 to like 2 by 3rds practically?
So you want us to tell you if we think something isn't fair. How are we supposed to know to do it this way and not the other way? Like, how are we supposed to know that that's exactly what you want?
Because of what you just asked me. You said, how am I supposed to do this?
But the question's really only, well, yeah, the question's really only phrased, graph the equation, find the area in between the curves, and then simplify it, and then use a calculator at the end to find the result.
It's just different, like simplify as much as you can.
Simplify as much as you can.
I just
but
think you can simplify this further.
How?
Because you gave me pi tenths, I think it was one of the answers to this
Pi tenths
equation.
is one of
Whereas
the
to me,
answers, yeah.
I think that basically amounts to this, that x is equal to the inverse sine of my negative 1/4 plus root 5 over 4. And so without identifying those pi tenths, do this. It's an angle, for which if I embed it in a right triangle, I think the ratio of the opposite side of the hypotenuse is going to be negative 1/4. Tell me if I'm writing the right numbers. Plus root 5 over 4, is that right? All over 1? Now I can use the Pythagorean theorem to compute this. It's going to be the square root of the square of the hypotenuse minus the square of the other leg.
So did anybody do this?
Yeah.
There was? All right.
Now, I would have to tremendously disagree on the etiquette of prettiness on that particular one versus sine pi over 5. I mean, you would be able to plug that into a calculator and you would get exactly the same answer as that. However, that is so much more uglier than sine pi over fifths, and you can evaluate both on a calculator just the same. Even that's
Well, I
even harder.
emphatically disagree in that if I'm on a desert island, I can handle that. That's much more difficult to handle. I can crank that out in sand. An approximation.
It's a great thing we're not on a desert island.
But you see my point? You're relying on technology. You're relying on the fact that your computer understands a power series representation for the sine function. Whereas for me, I just think this is the sine of twice this angle, which is 2 times the sine of this angle, times the cosine of this angle, times 2 times, the product of two fractions, piece of k. That over that, and that over that.
Where you put sine of x equals -2 plus or minus 4, that's just, you just use the quadratic formula in order
That's
to...
all I did. I mean, that's just a math issue, right?
Yeah.
And Bradley, I
We,
know
we
I-
just never did any of this in trigonometry.
No, you did. You had to.
No, we really didn't. My trigonometry
Really?
class was really easy. I don't...
Did you do it trig?
Yeah.
Okay.
Who did you take for trig?
Okay.
Yeah, okay.
But at least there's one word here. No, seriously, Bradley, that annoys me. Never. went
No,
this
we,
far
we
in
didn't
trigonometry.
we didn't do stuff like that in trig. Not at all.
No,
I mean, we
Bradley's
used
saying,
identities,
all
but we
things,
never
quadratic
actually...
formula, not tell me exactly what the angle is necessarily. You didn't have to write this, but know what the sine of the angle is so I can build a right triangle. Play the game.
We skipped a bunch of chapters and stuff like that in trig.
Did
I
you
mean,
do
it
this here
was...
at home?
Yeah, I took it with Professor... never mind.
And Bradley, notice I pulled a fast one on you.
Yeah.
I didn't consider the negative component. I'm just trying to beat that clock. This ends up being an angle outside a quadrant. Or outside whatever the interval was, not that I can remember what it was. That's why I cheated and just chose one of them. And by the way, there's another example where I did a ridiculous job grading. I graded all on the trigonometry and the algebra. I cheated. It was really a trigonometry quiz. You don't remember that? Really?
I remember using quadratic equation.
Do this for me instead, you guys. With what I've done on the board, now that I've done it, I want some honesty. Again, here too, I'm not going to get angry. How many of you think that was just wild? That's well beyond what you did back in trigonometry. So a vast majority of us. You know, I guess for those who do know me, when I give this take-home quiz, often I do cheat and I try to bring you back up to where I want you to be. So in the future, Bradley, what you can do is this. Say, I did a lot of work on this. And before you turn in and say, did I answer the question?
Okay.
I think with take-home quizzes, I'm not giving anything away by saying, I don't like that you didn't take this too far.
Okay.
I mean, I don't mind doing that because I want these take-home quizzes to be learning experiences. And I want you to be able to exploit them for points.
In San Jose, for sake of time, they said we were allowed to use graphing calculators because our classes were only 50 minutes each. So we had to fit, our tests within that amount of time. So doing this is just completely foreign. We were allowed to use calculators and they're allowed to use, pi over 5 as the answer because the teachers thought it was just redundant to have all this work.
See, I have to disagree. I don't think it's redundant. I think it shows you understand what's going on with the sine functions when you go through this process. I think it's so fundamentally important. In fact, when I get caught, particularly other institutions, teaching a class in 50 minutes, I will typically either break the exam up over 2 days or make part of it take home. so I can push things to an extreme. Because I really do think to further your study of math and science, you really need to be able to go through this. That's my honest opinion. I'm not trying to be a jerk. I'm not at home kicking my feet up saying, how can I trick you guys in an exam or quiz? I'm not doing that at all. I'm much more extreme on take-home stuff. And this is take-home. Only because you can access me outside of class. Right. More comments?
I think
Linda?
the difference for the take-home quiz was we were graphing where they intersect between, did you have all points of intersection or just the first one?
Just two, and I think the question was posed poorly. Here's what I intended. I don't remember the
I
exact
think that's
picture.
the issue because we only needed that one point. We didn't need all solutions.
Me too.
I think I said from 0 to something like 2 pi thirds.
Right.
Here's what I meant. I meant over the interval from 0 to 2 pi thirds, excuse me. Look at the one region that's bounded.
Correct. So we only needed one point.
These two.
Yes. So
But
we didn't need to go through, that's what I'm saying. So we didn't need to do all this because all we need to do is locate that one point.
2 points.
actually, you're right, Linda, but check this out. This one right here, the inverse sine of the sum of those two things,
Right.
ends up being that angle here, which ended up being, I think, this one.
Correct.
And so I still had to go through this work to get that one angle.
Yeah, but I said, 3x equals pi over 6, 2x equals pi over 2, add the two equations.
Oh, I know, but Linda, here's the issue.
Yeah, but that's all you need, because you know or is that like backwards?
It's not backwards, it's just
Knowing that where the angle of pi over 6, the sine of that equals the,
but I still don't think it's good enough for this reason.
okay.
Doing it that way, you found in your final answer things like this. And you were done. And I insist, I don't want you to be done. I want you to take that further.
Oh, I see what you're saying.
And I don't think you can take it further until you build your nifty little triangle, which you probably wouldn't have found unless you went to the nitty-grittiness of using the rational root here.
Gotcha.
In fact, that's what I really meant.
Makes sense.
All right, before we let this go, I'm just going to take a very quick peek then, see if I have any comments on the first page. I do. Can you go to number 5? When you look at the face, it's a semicircle. So question, is the equation a semicircle, which you will need, is that going to be x squared plus y squared equals 25? Why not? Why not?
The circle face up.
Because what?
The circle's raised above the origin.
But see,
The center of the circle face.
I think the answer to my question is you have no clue. Depends on where you put the x-axis. Do you see my point? And a lot of you answer the question, you didn't even label your x-axis. I couldn't even address whether or not you're correct or incorrect because you didn't fill in your picture. So I can't tell if you got the right equation unless you show me where the x-axis are. Do you see my point? Something else I saw a lot of, and I saw also in past quizzes this summer session, and I keep forgetting to say it. I want a yes or no answer.
No,
Is this a true statement? What do you mean no? Why not?
because, yeah, that is, yeah. Yeah, never mind.
Thank you. What am I saying? I don't think it's a statement at all because a statement is a sentence and it's got a noun in the subjective position, it's got a verb, it's got a noun in the objective position, and I think there's no verb. I really meant this, didn't I? No, I didn't. No, I still made a mistake. I really meant. Do you guys see my point? Make a full sentence. That equal sign is fundamentally important. Tell me you understand these things are equal to each other. Write a smooth flowing sentence. You know what? I don't think there's any other comments I have on this. No, nothing left. All right. If you guys don't have any questions and exams, what about here? Anybody? Is the homework going okay? You know the homework, the work you do outside of class.
Do the integral of cosine of square root of x.
Wait, cosine square root of x.
What number was that?
Is it 55? If you guys just relax, don't do any work, don't do any writing. I want you guys to kick your feet up and tell me which one of these two approaches on the middle board or the right board in blue is going to be the best approach.
Correct.
They're both horribly incorrect. I think they're horribly incorrect because that is not multiplication between the COS and root x. That's functional composition. I think the only choices I really have, let me fix this in blue, are these two. I want somebody to talk about the second approach in blue that's on the right ink board. Say something.
Same thing.
There's no reason for writing it because I think it's begging the question. It's the same question as what I have in the original question, isn't it? To anti-differentiate, this means I'm going to value this integral, so I think it just doesn't do any good on the right-hand ink board. Do you guys agree? So I can't look that far ahead. I really am not looking that far ahead. I'm tired. But I think the only approach I have with integration by parts, the only choice, is what's in the middle ink board. Let's see if it helps. Let's give it a shot. Paying the consequence of my actions and differentiating. And anti-differentiating. Let me commit to my integration by parts formula. Are you saying I can't differentiate? Thank you. Actually, it's worse, it's negativized. So I know that. And in committing to my integration by parts formula, I suppose that means that this one particular integral I started out with is nothing more than a product of my u and my v. Minus the integral of my v du, which in this case will be a positive 1/2. You guys, I can't. I'm still not writing correctly. I said out loud in English uv. I didn't write it. uv is equal to this mess. However, minus the integral of my v du, which in this particular case gives me a tad bit of cancellation. Would that be, is that just a root x? Sine root x? And I admit, you guys, I'm panicking. I'm starting to get nervous only because I use integration by parts typically to replace my one integral with an expression involving another integral that's easier to evaluate. But when you take a peek at this integral, I think it's just as nasty as this one. Actually, my choice of words, just as nasty, are good choices of words. Because this is just quite as nasty as what I started with, maybe this suggests what I can do is do it again. Maybe solve an equation.
What happened to the, because it's integral of v du, and then root x underneath, you just cancel? Oh no, you can't cancel.
I did. I canceled this root x with one root x here. There's one root x that remains standing.
I gotcha.
I did perform a tad bit of cancellation. So you guys, if you don't mind, I'm going to commit to this again. If I now let my new u be equal to this time the cosine of root x, and dv be everything else, committing to this, du similarly is this. Did I choose the wrong function again? Jeepers. Is that sine, not cosine? But I think its derivative, like before, is just as easy. I think his antiderivative is a piece of cake. And now, if I commit yet again to my partial fraction decomposition, jeepers, commit to my integration by parts formula, speaking days in advance, I think what it tells me is I can rewrite this entire line. I'll rewrite it. I think it tells me that the integral of the cosine of root x with respect to x is merely my x cosine root x plus 1/2 times some stuff. Now slow down.
Yeah.
Did I really wear
The second dB.
the second dv?
Root x times sine of root x? And that root x just disappeared?
Yeah. The second one like that.
Instead of
So
saying,
sine root x.
My apologies, you guys. I'm just running amok today, aren't I? I completely missed it. But I think, Deborah, what you're saying then is I've really made a mistake. I think in a sense, this isn't just as nasty as this one. I didn't even see the root x factor. I think it's, in a sense, worse. All right, I blew it. I really did. So tell me how to fix it. Back here with my choice of u and dv. What do you think I should assign? Anybody?
Do the trigonometric first.
What do you mean? You mean the sine root x?
Yeah.
If you're going to commit to this, that means everything else is going to be my dv, which in this case is going to be my root x dx. It's just if I anti-differentiate that, what does that generate? It's going to be a, so 2/3 x root x, or you're right, x of 3 has to be the same thing. Over here, I think what that's going to give me is, yeah, instead of positive sine root x over 2 root x dx. Man, oh man, I'm just a mess today. However, I think in the integrand's position, let's have it more cancellation. I'm going to end up with this. Is that my 1/2? I guess I get my 1/2 times the product of my new u and new v, which is going to be 2/3 x root x. Is that the sine of root x? Minus the integral of my v du, but don't forget there's a factor of 1/2 sitting up front. And so I think in the end that's going to give me 1/2. Times another 1/2. Times, is that a 2/3? Times the integral of something times the cosine of root x with respect to x, but what's being multiplied with the cosine? Anybody?
1 over.
I think it's going to be a factor of x. Because I cancel with these root x's, upstairs and downstairs. I don't know, you guys hear me? Is this getting me anywhere? Is this helping? Can you see the pattern? If you look carefully at the pattern, it's almost as if I'm coming in and saying, no factor of x. But now applying integration by parts once, I introduce a factor of root x. Integrating by parts again is apt as forcing another factor of root x, which gives me full x. I think what's happening with this x factor is increasing with this exponentiation. The power to which x is being raised to is increasing. And so I think if I stand up here and apply integration by parts one more time, I'm going to get maybe a sine expression here times x root x. Do you guys see that's an issue? Everybody? Any other ideas? Do you agree with me this is not helping? In the long run. What about in the short run?
You would just subtract it over or add it to the other side. Oh no, never mind.
All right, how about this? I have no problem applying integration by parts once, but I'm the one in front of the entire class, didn't realize I got an extra factor here I didn't see. This stage of the game, right here with this interval. Instead of applying integration by parts again, since you guys see this doesn't work, can I erase this? This doesn't work. Check out what would happen if I did this. Instead of with integration by parts, if I came in and committed to this u sub, then I think paying the consequence of my actions, I get this. And now in rewriting this blue line, I think it's going to give me the following. I think if I rewrite this as plus the integral of 1 over 2 root x times the sine of root x with respect to x. Is it not true that everything above this brace, isn't it the same as this? Everybody?
Isn't it?
What do you mean, no? Why not?
Oh, no.
What am I missing?
You still have to multiply by 1/2.
I got it right there. I marked it.
You have to use sub.
No, I think it's worse. I think since this factor is root x, and I wanted a root x downstairs, it just simply means I need to introduce a factor of it. Looks nice. Now, in committing to a u sub, that u sub right there, I think that gives me Oh, same stuff. Plus, this whole new integral, which has a whole new alternative name of u squared sine a u du. Did you guys see my point?
No.
Oh, you don't?
No, where'd you get the X from?
Do you agree with this? The factor of root x there.
Yes.
Do you agree that x over root x is just simply root x?
Yes.
But how, root X over where'd you get, I mean, like, where'd you get the X? Did you just put it in there?
No, I did something different. I put this in there. I put the 1 over 2 root x in there because I wanted to commit to this u sub. I needed a 1 over 2 root x factor in there. And so I slipped it in. It's not legal. I made it up out of thin air. Well, I shouldn't say I made it up out of thin air. I already had the factor of x, a factor of 1/2. But I did put the root x downstairs, which I didn't have. But I did have a root x upstairs. I just think x divided by root x is equivalent to my root x. I think what you see above this black brace is identical to what I have above this black brace. I think they're the same. And if you see it, then check this out. Yes or no answer, if you can read it. Look what's triply undermined. And it's an honest question. Is that a piece of cake to die here?
You still have to do
Do what?
the integration by parts.
How many times?
2 more times.
Can you look ahead and play chess and recognize that it works?
Yes.
Yeah, it really does, because now that I've got not root u's, but u's, I think reduction of order technique applies. I think now in applying integration by parts one more time, where my z equals u squared, I get to whittle this down to an expression involving an integral, which is a u sine u. But then applying integration by parts again, I get to reduce that exponent down to 0, and I'm just going to have a constant times the sine of u, piece of cake. That'll work. Did you see it, Randall?
Yeah.
But I'm serious. I'm the one who flubbed up, and I was thinking this is the same as what's in there. Just sines replacing cosines. And that's it. You sure that was okay with everybody? You guys, is there anything left in the homework? Okay, if not, then allow me to do this before the break. Because I think what you and I now are embarking on is finding techniques of integration. And as far as what you and I have right now, we don't have a lot in our back pocket. Number one, we've got our fundamental theorem of calculus. Number two, we've got that old substitution technique. Then you and I, last time in class, got a bit more sophisticated, and we discussed a whole new technique that I refer to as integration by parts. And you guys, today I've got quite a few things to discuss, but taking small steps. What I'm going to do next is talk about trigonometry. Integrals. I will assume you do not know this topic. I assume you've never seen these integrals, but for those of you who have, I'm not referring to trigonometric substitutions, at least not yet. I'm simply referring to integrals in which I've got trigonometric expressions in the integrand's
So
position.
is this gonna cover like, inverse trigonometric functions like, as well?
You know they'll pop up naturally, but not as much as with trigonometric substitutions, which I'll discuss it later, maybe even today.
So are those how we're supposed to solve?
Yes.
Okay.
I agree. And if you guys don't mind, can I start up with examples that illustrate how I break this up? And you guys, we're going to take a break in a few minutes. So do you mind if I start out really slow? I'll just give you one example for the break, and it's a very light one. However, give an interval involving the sine or cosine of x to simply the second power. I think life is a piece of cake in a variety of different ways. I have more than one way of actually evaluating this interval. But a natural way to answer this question, I think, is to evoke one of your half-angle identities. I think another name for the sine squared of x is 1 minus the cosine of 2x all over 2. You guys, here too, roughly speaking, this is kind of reduction of order technique, isn't it? In using this one trigonometric substitution, I have replaced the integral involving a sine function to a relatively high power of 2 with an expression involving this cosine function, or sine, who cares which, raised to only the first power. Life's a piece of cake. I think this ends up being nothing more than this integral minus this interval. The first of which is no issue whatsoever. The second of which only involves one tiny, tiny little issue, maybe making a use of in our heads. If we allow u to be 2x, du is 2dx. Or shall I say, dx is 1/2 du. And I think that would give me a minus 1/4 sine of 2x. Do you guys agree? So I think when it comes to sine squared of x or cosine squared of x, life is that easy. You know, maybe I can make it slightly more complex by doing something to a higher power, or taking that to a higher power. But you guys think I could just let you mold it over for 10 minutes before I look at it? We can take our 10 minutes. We can cool off. And maybe after the break, if you guys don't mind, I'll leave the door open. This is so hot.